Hello guys, in this video we're going to see the particle movement subsurface in application with hydraulic gradient. So let's start our video, make a new file, select my new folder, exercise 20 and make a file, exercise 20, save it. First, sorry, first mesh size, number of layers 2. Number of straws 30, model extend up to 300 meter. Number of columns 40 and extend up to 400 meter. Okay. As you know, like in previous video, to remove the extra area of the sheet, go to option environment coordinate system. X1 minus 20, Y1 minus 20, X2 420 and Y2 320. Now save it. Layer property, both layers are transmitivaries. It's okay, fine in all cases. Cell status I want Modflow. Right click, make it -1 for the constant. Select copy and by using arrow keys of a keyboard, make a boundary around your domain in both layer 1 and layer 2. It is for layer 1 and to copy, select this tab and go to second layer. Now it is also copied to the second layer. Now parameters, time, change second to days. Initial prescribed hydraulic head, assuming it -1 for entire model. It's mean for both layers. Reset matrices, horizontal hydraulic conductivity, taking it as a 1 and save it. Vertical hydraulic conductivity 0.1, apply to entire model and save it. Now effective porosity, taking it 0.1, apply to the entire model and save it. Now go to mesh size, subdivision of the grids, 2 column and 2 rows, copy. Here also it seems good now. Now save it. Now we're going to place our well locations for injection and production well. In layer 1 we're going to place our injection well 25 cubic meter and here also 25, and in layer 2 we're going to place our production well -50. Now save it, go to flow packages and set a recharge value. Eight 8.2 is to power -5. Now save it. Now after that we will go to tool and digitizer for the making corner points of hydraulic gradient. If we consider that our hydraulic gradient is 1 meter per kilometer, so it's 1 meter per 1000 meter. So we're going to divide it by 1000. It is 0.001, and we have length of our column lengths are 400 meter. So we're going to multiply by 400. Our hydraulic gradient of this study area is 0.4. So if I consider that the eastern part of my study, western part of my study area having hydraulic gradient of 2.2, so -2.2, then the western part would be 1.8. So I'm going to mark a point minus 2.2. Here also minus 2.2, and in the eastern part I have by right change it to minus 1.8, and also here minus 1.8. So the hydraulic gradient moves from east to west. Now we're going to save our points. Now save it as a corner points. Now go to field interpolator. Select the file of a corner points. Now output file name it as a matrix uh, folder exercise 20 corner points exercise 20 corner points. Now output name it as a matrix corner points. Grid position we need nothing but search and gridding method make it change it to simple data per sector 4 and gridding method anchor triangulation. Go. That is now completed. Okay. Going to initial prescribed hydraulic head and matrix. We're going to replace this matrix by our matrix file. Browse it in a folder matrix corner points. Okay. Now we can see the hydraulic gradient from minus 2.2 to 1.8. Load. Okay. Now we need to check it. Select contours. Fill contour visible level. Make it minus 2.2, minus 1.8, and interval of 0.05. Label format fix. Yeah, it seems good now. The hydraulic gradient of our sheet or a study area is from the flow direction from the east to west, and you can see here a values minus 2.15, 0.1050, 1.95, 1. And so on. And before going to process, we also need to copy it to the second layer. It is now copied. Save it, yes, and we're going to run our model now. We generate our input files. Yes, seems good. Now go to PM path. We need to provide particles for the simulation or modeling. Number of particles 30, radius 1.5, and number of layers 3. Provide it to second injection well also, and go to second layer. Now to the production well. Seems good now. Go to particle tracking. Step and 30, maximum steps 12. Outline color for layer 1 make it blue, and for layer 2 change it to red. Check the step and OK. Come to layer 15 column, 15 raw and 20 column. Go to environment, 15 raw and 20 column. Exaggerate up to 5. OK. And particle tracking all done. Now for the hydraulic head. Now I need to see the contours. So now here it is, and we need to see the flow of our particles in case of a hydraulic gradient after the application of the hydraulic gradient. So we're going to see, yes, see the south in the south of the sheet, the particles are moving towards the production well from high concentration towards low concentration, and in the north part of the sheet, the particle movement are in the direction of the northwest direction. So as you know that our hydraulic gradient of a sheet is from east to west. So particle also clarifying it that all our particles from the layer 1 and layer 2 are moving towards the western direction. And in the south part, due to presence of a low concentration zone, which is our production well, particles are moving towards the production well. Thank you. Take care.